In this lesson, we will explore the concept of zeros of quadratic functions and determine the zeros of quadratic functions both algebraically and graphically. Now, when looking at zeros of the quadratic functions, keep in mind zeros represent the x-intercepts when you're graphing a quadratic function and where the parabola crosses the x-axis. Zeros also represent the solution, and it also represents the roots. So all those are essentially the same thing. So keeping that in mind, do you think all parabolas have exactly two roots? And I think we've already explored that. We've seen many times that a quadratic function, when graphed, the parabola may cross the x-axis twice, so have two roots or two zeros, but also we've seen that the vertex can be found on the x-axis, which means it's only one point crossing that x-axis, so that means one zero or one root or one solution. But we've also seen where we've had the vertex of the parabola above the x-axis and A is positive. That means opening upward. So that parabola will never cross the x-axis. Or we've seen the vertex below the x-axis and A is negative. So it's opening downward, which means, again, that parabola will never cross the x-axis. So in that scenario, we have 0 zeros, so no zeros, 0 roots, and no solutions. So without further solving, there is a way to determine the number of zeros a quadratic function has by simply calculating its discriminant. Now, if you recall the quadratic formula, the discriminant actually is derived or comes exactly from the quadratic formula. The discriminant is the expression underneath the square root, and that can tell us whether our function has two roots, one root, or 0 roots. And the discriminant formula would be, like I said, the expression underneath the square root, which would be b squared minus 4ac. Keeping in mind when we have the quadratic function in standard form, a is the coefficient in front of x squared, b would be the coefficient in front of x, and c is your constant. So some key concepts: a quadratic function can have either 0, 1, or 2 zeros. The number of zeros can be determined when using the discriminant. If b squared minus 4ac is greater than 0, then the quadratic equation has two real roots, or two zeros, two solutions. If, however, b squared minus 4ac is equal to 0, that means the quadratic equation has one real root, or 1 0. If, however, b squared minus 4ac is less than 0, so that means a negative value, then the quadratic equation has 0 real roots. So 0, 0, zeros, and so no zeros and no x-intercepts. So looking at example 1, knowing our knowledge of what a quadratic function will look like, determine the number of zeros for each quadratic function by graphing them. So we're just going to take apart each of these quadratic equations, or functions I should say, and reminding ourselves that when A is negative, the parabola will be opening downward. If A is positive, it's opening upward. In example 1, each of our examples are expressed in vertex form. So that means we can find out a lot about this function, how it's going to look like graph. So A is negative 1, so we know it's opening downward. And the vertex is negative 2 and positive 3. Okay, so basing on that, we can plot at negative 2, positive 3. Now, because we are given the actual equation, we can just sub in some values to the right and to the left of the vertex in order to get a better idea of what this graph is going to look like. So when x is negative 2, if I move to the right, when x is negative 1, I'm just going to sub it into the function given, following by as always. So negative 1 plus 2, which is 1. 1 squared is 1. 1 times the negative up front is negative 1 plus 3 would be positive 2. So we know, again, quickly draw my axis of symmetry. Okay, because I have that axis of symmetry, to the left, I have another coordinate. But let's add another point. Let's say when x is 0. 0 plus 2 would be 2. 2 squared is 4 times negative 1. So negative 1 times 4 would be negative 4 plus 3 would be negative 1. So at 0, we're at -1. Okay, so it doesn't ask us what the zeros are, but clearly we have the parabola crossing the x-axis at 2 points. So therefore, there are 2 real roots slash zeros. Looking at the second example, again, A and the vertex tells us a lot about what this function will look like and whether we would have 1 0, 2 zeros, or no zeros. So the A value here is +2. That means it's opening upward. And we also have that the vertex in this case is -1 and +1. So if we look at -1 and +1, again, we just need a little sketch, but we know it's opening upward, so we don't even have to have an accurate graph to say we know that this particular function has no zeros, 0 real roots. Therefore, there are no zeros real roots. Okay, we can just determine that automatically because we know the vertex is above the x-axis and A is positive, so it's opening upward. Looking at C, we have f at x, so we know A is equal to +4, which is opening upward because it's positive. And then we know the vertex in this case is -3 and 0. So if we're looking at -3 and 0, again, just a quick sketch. But because the vertex is on the x-axis, we can say, therefore, there is 1 0. Again, or we could say real root or 1 x-intercept. Okay, and that's determining how many zeros we have based on the graph. Example 2, we're going to explore, determine the number of zeros for each quadratic function. And this time we're going to use the discriminant because the discriminant does tell us how many roots that quadratic function would have. Roots or zeros are the same thing, just to reassure that. So because of the function given is in standard form, we can say A is equal to 2, B is equal to 4, and C is equal to 1. So we are going to figure out what is that discriminant value. And as we saw earlier, if it's greater than 0, we know we're going to have 2 zeros, 2 real roots. If, however, it is equal to 0, then we know we're going to have 1 real root. And if the discriminant value is less than 0, so negative value, then we have no zeros, no real roots. So let's determine that. So we have D is equal to, so keeping in mind discriminant is equal to b squared minus 4ac. So we will determine the value, and then based on that, we can determine how many zeros we have. So we have d is equal to b squared, so 4 squared minus 4 times a times c. So discriminant is equal to 16 minus 4 times 2, which is 8 times 1. So the discriminant is equal to 8. So therefore, discriminant is greater than 0. Therefore, 2 real roots slash zeros. Okay, looking at B, we know A is equal to 2, B is equal to 4, C is equal to 2. Again, determine the discriminant, and from there we can decide how many zeros the quadratic function is. So we would have D is equal to 4 squared minus 4 times A times 2. So 4 squared we know is 16. 4 times 8 times 2 is minus 16. So D is equal to 0. Therefore, 1 real root or 0. Looking at C, again, A is equal to 2, B is equal to 4, C is equal to 3. So the discriminant is equal to 4 squared minus 4 times A times C. So d would equal to 16. 4 times 2 is 8, times 3, which is minus 24. So d is equal to negative 8. So d is less than 0. Therefore, 0 real roots slash zeros. Okay, looking at example 3, we need to determine the values of k for which the quadratic function f at x equals x squared plus kx plus 4 will have each number of zeros. Again, in this type of example, we want to consider our discriminants. We know the discriminant is equal to 0 if we have one real root. The discriminant is greater than 0 for two real roots. And if the discriminant is less than 0, we have no real roots. So we're going to use that to help us determine what values of k will satisfy these conditions. So again, looking here, a is equal to 1, b would equal to k, and c is equal to 4. So we know if we're looking at one real root, the discriminant b squared minus 4ac has to equal to 0. Two real roots, we know b squared minus 4ac has to be greater than 0, and the discriminant b squared minus 4ac has to be less than 0 if there's no real roots. We're going to use that information to help us decide what values of k would make this true. So b we know is k. Remember, substituting everything in brackets. 4 times 1 times 4 is equal to 0. So k squared minus 16 is equal to 0. K squared, solve for k, is equal to, bring that 16 over, which is positive 16. Take the square root of both sides. So plus or minus k is equal to 16. Therefore, sorry, not 16, but rather the square root of 16 is 4. So therefore, we know that k is either equal to plus or minus 4. Okay, so if k is equal to positive 4 or if k is equal to negative 4, we will have one real root. Now, following that, the discriminant has to be greater than 0 for two real roots. What values of k will make this particular function have two real roots? So following along again, k squared minus 4 times 1 times 4 has to be greater than 0. So then again, we'd have k squared minus 16 has to be greater than 0. So k squared is greater than positive 16. Again, taking the square root of both, plus or minus k has to be greater than 4. So keeping that in mind, that means either k is greater than 4 or negative k is greater than 4. But we don't want that negative up front. So we're going to divide both sides by negative. And keeping in mind, when you divide by negative value, you make sure to change the sign of the inequality. So therefore, in this case, the function will have two real roots when the value of k is either greater than 4 or the value of k is less than negative 4. And likewise, in the first, I forgot their first statement, but therefore the function will have one root when k is equal to positive 4 or k is equal to negative 4. Okay, so no real roots. So we'll have to substitute b is k minus 4 times a times 4. Now it's less than 0. So k squared minus 16. So we're going to say k squared is less than 0. Sorry, less than 16. Positive 16. And then again, taking the square root of both sides. So plus or minus k is less than 4. So we're going to say k can be less than 4 or negative k is less than 4. And again, we have to make sure And again, when you divide by a negative, you have to make sure to change the inequality. It has to be greater than -4. Okay, so therefore, the function will have no real roots when k is less than 4 or k is greater than -4. Okay. Example 4 we have, find the quadratic function with the integral coefficients having the given zeros. Now we're working backwards in this question. Now we're given the zeros and we need to figure out what the quadratic function will be. So think of it, setting it up as working backwards. So we have x is equal to 3 over 2, and then we have x is equal to -1/2. Now, to move backwards, we have to remember when we isolated, we had two binomials equaling 0. So actually, when we simplified, x equals 3 over 2 is part of that binomial. So let's work backwards. If we know these are our roots, I need to make sure I get rid of that fraction first. So it's 3 divided by 2 on one side. When I bring that over, opposite of division is multiplication. So this becomes 2x is equal to 3. Likewise, we have, bring that 2 over. If you're dividing by 2 on one side, it's going to be 2x is equal to -1. Okay, so if you remember, when we isolated, it would be 2x minus 3 is equal to 0, and 2x plus 1 has to equal to 0. And then we would have those two binomials. And of course, in order to expand the two binomials, we follow FOIL. 2x times 2x, which is 4x squared, 2x times 1, which is 2x, -3 times 2x, which is -6x, -3 times 1, which is -3. And of course, collecting like terms, we have 4x squared minus 4x minus 3 is equal to 0. Okay, likewise in B, we know x is equal to -2. That is 1, 0, or 1 root. Okay. 7 over 2. So in this case, we bring the 7 over. So this becomes 2x is equal to 7. X, bringing over that -2 becomes s plus 2 is equal to 0. And here we have 2x minus 7 is equal to 0. And we can say, therefore, x plus 2 times 2x minus 7 would equal to 0. Expanding, x times 2x, which is 2x squared, minus 7x plus 4x minus 14 is equal to 0. Okay, simplifying our like terms, we have 2x squared minus 3x minus 14 will equal to 0.